On the 12th of December, 1989, a dragline operator cutting a new pond on a golf course in Licking County, Ohio, felt his shovel catch on something and stop. It had struck a skull. Over the next 3 days, in bitter cold and blowing wind, a team lifted out the most complete American mastodon skeleton ever recovered anywhere. The animal had died roughly 11,500 years ago. Its stomach contents were still there. And when the anatomists went over the bones, they found marks that should not have been on them. Cut surfaces, polished patches, breakage in the wrong pattern. One researcher argued the animal had been butchered and its meat sunk in that pond on purpose. More than 30 years later, that claim has still not been settled, because the one thing nobody has ever found at Burning Tree is a single stone tool. Heath sits in southern Licking County, about 30 miles east of Columbus. It is not wilderness. It is not remote. The Burning Tree golf course had been open for years, and in the winter of 1989, the grounds were being expanded, which meant cutting a new pond into a low, wet corner of the property. That corner was wet for a reason. It was a kettle basin, a hollow left in the ground when a block of stranded glacial ice melted out at the end of the last ice age, and it had been filling with peat ever since. Peat is soft. Peat is easy to dig. And peat, because it is waterlogged and starved of oxygen, preserves organic material for thousands of years when everything around it has rotted away to nothing. The contractor was Flower Excavating. The machine was a dragline, which works by casting a bucket out across the ground on a cable and hauling it back in long, heavy poles. It is a tool for moving earth in bulk and quickly. It is not a tool for finding anything. On the 12th of December, the bucket caught the skull of an American mastodon and broke it. The operator felt it go and looked at what he had pulled up. What happened next is the part that decided everything. The operator stopped. The word went out, and within a day, the Ohio Historical Society and the Licking County Archaeology and Landmark Society had people on the ground. Bradley Lepper, then the Society's archaeologist, took charge of the recovery. Volunteers came from several organizations. Nobody had a season. Nobody had a budget. What they had was an open hole in a golf course in the middle of December. The excavation took 3 days. It was carried out in bitter cold and blowing wind, in a pit cut into saturated ground by people working with their hands in freezing peat. 3 days is not a field season. It is an emergency. What came out of that pit was a nearly complete American mastodon, a young adult male. Most of the skeleton was there, and much of it was still in anatomical order, the bones lying more or less where the body had left them. No other mastodon recovered anywhere in North America has ever been this complete, and the peat had done something else. Inside the rib cage, where the intestines had been, there was a mass of dark, fibrous material that had not decayed. Plant matter, twigs, bark, seeds, and aquatic vegetation, still recognizable after 11,500 years. The animal's last meals were sitting in the ground where it fell. That figure comes from radiocarbon work on conifer wood recovered with the skeleton, which placed the death at roughly 11,500 radiocarbon years ago. Calibrated against the calendar, that lands close to 13,000 years. Either number puts this animal alive at the end of the last ice age in the same centuries on the same landscape as the first people known to have been in Ohio. The preservation went further than anyone expected. In 1994, researchers reported isolating living bacteria from the intestinal contents, organisms that had survived in that peat since the Pleistocene. The work was published in the microbiological literature 4 years later. Whatever else was in dispute about this animal, nobody disputed the ground it came out of. The peat had held everything, which is what makes the next part so difficult. A skeleton that complete, out of ground, that preserved even the stomach contents, recovered in 3 days by people who documented what they lifted, ought to settle questions rather than open them. Instead, when the bones were cleaned and laid out and examined properly, they carried a set of features that nobody has been able to agree about since. Cut surfaces on the ribs, polished areas where polish should not be, bones broken in ways that fresh bone breaks and old bone does not. Bradley Lepper, who had been in the pit himself, would later describe the whole thing with a phrase that has stuck to the site ever since: a forensic mystery. The man who read those marks was Daniel Fischer, a paleontologist at the University of Michigan, and he did not come to the burning tree skeleton cold. He had spent the previous decade doing something nobody else in the field was doing. He was reading mastodon and mammoth bones the way a pathologist reads a body. The method matters, so set it out properly. Fresh bone and old bone do not break the same way. Fresh bone still has collagen in it and still holds moisture, so it behaves a little like green wood. Hit it, and it fails along a curved, twisting line, and the broken surface comes away smooth and angled. That is called a spiral fracture. Dry bone, months or years after death, has lost the collagen and snaps straight across, square and rough. If a bone in the ground shows spiral fracturing, something broke it while the animal was still fresh. That narrows the list considerably. Fischer published the framework in 1984 in the journal Paleobiology, applying it to a set of late Pleistocene mastodon occurrences across the upper Midwest, and arguing that a subset of them showed butchery by Paleo-Indians. So when the Licking County skeleton came out of the peat in December of 1989, there was already a published method waiting for it, and a researcher who had spent years learning to apply it. He worked on the material with Bradley Lepper and Paul Hugi. A preliminary taphonomic analysis appeared in 1991. The full argument was published in 1994 in a volume issued by the Ohio Archaeological Council under the title The First Discovery of America. What they described was 4 separate lines of damage on one animal. The first was cut surfaces, marks on the bone that are narrow, straight, and cleanly walled, of the kind a sharp edge leaves and a tooth does not. The second was breakage, spiral fracturing on limb bones, indicating that the bones went through whatever happened to them while they were still fresh. The third was charring, burnt surfaces on parts of the skeleton. The fourth was polish, small, smoothed, glossy areas on particular bones in particular places. Polish forms when a surface is rubbed repeatedly against something harder, and it is the least intuitive of the 4, which is exactly why Fischer found it useful. It is difficult to produce by accident. Any one of those on its own is arguable. A tooth can score a bone. A tree root can groove it. Sediment moving under pressure can smooth it. Fischer's case was that the 4 occur together, in a coherent arrangement, and that a natural process producing all 4 in the same pattern on the same animal has never been demonstrated. Then he went further, and this is where the argument stopped being about damage and became about behavior. Consider the practical problem a hunting group faces after killing an animal the size of a mastodon. There is more meat in front of them than a small band can eat before it rots, and every scavenger and predator within range will be arriving shortly. The meat is not the achievement. Keeping it is. Fischer's proposed answer was the pond. Cold water at the bottom of a kettle basin sits near freezing for much of the year and holds almost no oxygen, which slows spoilage and puts the meat out of reach of anything that hunts on land. Sink the carcass in sections, and it keeps. Come back through the winter and take what you need. He did not simply assert this. At another site, in Michigan, he and his colleagues found masses of sand and gravel resting on the floor of an ancient pond, and argued that people had packed the animal's own intestines with the material to make anchors, weighting the meat so it stayed down. His former graduate student, David Fox, has described the reaction among colleagues plainly, that nobody else would have arrived at that idea. And then Fischer tested it on himself. He butchered a dead draft horse, sank the remains in a Michigan pond, and over the following months went back, pulled up joints, cooked them, and ate them to find out whether the meat was still good. It kept. That is the part of the experiment that gets repeated, and it is the part that matters least. Because the response to Fischer's reading of the burning tree skeleton did not come from people arguing that meat cannot be stored in cold water. It came from people asking a much harder question, and the hardest version of it came from the man who had been standing in the pit. Bradley Lepper co-authored the 1994 butchery paper. He has also said, publicly and repeatedly, how difficult he found it to accept the argument he had put his name to. That is an unusual position for a scientist to hold in the open, and it is worth understanding why he holds it, because his objection is not about bones at all. There are no stone tools at Burning Tree. Not few. None. No flakes, no cores, no points, no scrapers, nothing struck or worked. An animal that a group of people supposedly killed or scavenged, cut apart, burned, and moved into deep water in sections, and not one piece of the equipment that work would require was left behind anywhere in that basin. Consider what that absence does to the argument. Archaeology establishes human presence primarily through objects that only humans make. Take those away, and the case rests entirely on marks, and marks are interpretations. Lepper's position has been consistent. Without stone tools placing people at that spot, questions will always remain in the minds of archaeologists. He has said so while continuing to regard Fischer as a careful thinker, both things at once. And there are competing explanations for each individual line of evidence. Spiral fracturing establishes that a bone broke while it was fresh. It does not establish what broke it. A large carnivore working a carcass produces fresh bone breakage. So does the weight of a heavy animal collapsing onto its own skeleton in soft ground. So, in some circumstances, does sediment loading in a peat basin over time. Cut surfaces are the strongest of the four lines, and even they are contested. Trampling by other large animals drags grit across bone and leaves narrow scores. Carnivore teeth leave marks that can be difficult to separate from tool marks without high magnification and careful comparison. Polish is the least intuitive and therefore the most argued about. Fine sediment moving repeatedly against a bone surface produces smoothing. So does the movement of the bone itself within a matrix that is slowly compacting. Charring is real, but fire has more than one source on a landscape, and burnt bone in a wetland deposit does not by itself carry a signature that says a person lit it. None of this proves Fischer wrong. His argument was never that any single mark is decisive. It was that four independent kinds of damage occur together in a coherent pattern, and that no natural process has been shown to produce that combination. That case still stands, and it has not been dismantled. But there is a structural problem underneath it that goes well beyond one mastodon in Ohio, and it surfaced hard in 2017, when a team argued that broken mastodon bones and stones in California recorded human activity 130,000 years ago. The response was severe. Gary Haynes, emeritus professor of anthropology at the University of Nevada, Reno, wrote that the claim rested on an argument from ignorance, meaning that not knowing what natural process could have caused the damage is not the same as knowing that people did. Lepper, who had lived with the same problem at Burning Tree for nearly 3 decades, was among those unconvinced by the California case. That is the shape of the whole dispute. Bone modification arguments carry enormous weight when they are right, and they are extremely difficult to close. So Burning Tree sits where it has sat since 1994. The most complete mastodon skeleton in North America, out of ground good enough to preserve its stomach contents and living bacteria, carrying 4 kinds of damage that are hard to explain and impossible to prove, and not one stone tool to settle it. Which raises the obvious question. Who was actually in Ohio at the time, and what can be proved about them? Go about 70 miles northwest of Heath, and you reach Wyandotte County and a place that answers that question with objects instead of interpretations. Sheridan Cave is not a cave anyone can walk into. It is a sinkhole in a dolomite ridge near the village of Cary, part of a system now known as Indian Trail Caverns, and its entrance had been sealed by sediment for thousands of years. Below the plug, the passage runs down some 50 feet into deposits that had been accumulating undisturbed since the end of the last ice age. Kenneth Tankersley, then at Kent State University, published the first account of the site in 1997 in the journal Geoarchaeology. Brian Redmond, of the Cleveland Museum of Natural History, joined the work and led it forward across 4 further years of excavation. What they were digging was a sealed, stratified, deeply buried late Pleistocene deposit. The word sealed is doing real work there. At Burning Tree, everything depends on reading damage because the context cannot rule out natural agents. At Sheridan, the context is a closed sinkhole with layers stacked in order and nothing moving through them. The animals came out first. Giant beaver, Castoroides ohioensis, the largest rodent ever to have lived in North America. Flat-headed peccary, short-faced bear, elk moose, Servalces scotti. Hugh Gregory MacDonald, who worked on the fauna, published an overview in 1994, placing most of the dated remains between roughly 13,000 and 9,500 radiocarbon years, with the elk moose considerably older. Then the artifacts. A carved bone point, incised and beveled at the base. A second bone point alongside it. A fluted Clovis projectile point that had been reworked, meaning somebody broke it and reshaped it to keep using it. A side scraper made from a bifacial thinning flake. A bifacial preform. Chert debitage, the waste flakes that come off a stone core while a tool is being made. Burnt bone. Scrapers, drills, and points made from chert, quarried more than 200 miles away, and the neck bone of a snapping turtle carrying tool marks on it. That last one is worth pausing on because it is the kind of detail that does not make headlines and settles arguments anyway. Somebody was processing a turtle in that cave with an edged tool. Then they dated it, and they did not do it once. Redmond has described more than 30 radiocarbon assays from a single section of the deposit. The dates on charcoal placed the human occupation between roughly 10,400 and 10,900 radiocarbon years ago. In 2009, Michael Waters and Thomas Stafford, working with Redmond and Tankersley, published a direct date in the journal American Antiquity, run not on charcoal near the artifacts, but on collagen extracted and purified from one of the bone points itself. 10,915 radiocarbon years, plus or minus 30. Calibrated, that lands close to 13,000 years before the present, inside the accepted Clovis window. Consider what the plus or minus 30 actually means. That is a 30-year margin on a measurement of nearly 11,000 years. The burning tree argument has been running for more than 3 decades without resolution. This one was closed by chemistry, on the object itself, to a precision finer than a human lifetime. Sheridan Cave is now routinely described as one of the best dated early Paleo-Indian occupations in eastern North America, and it sits alongside Shawnee Minisink in Pennsylvania as one of the very few places where Clovis-era tools are tied directly to a date rather than to a layer near a date. So the answer to who was in Ohio is not in doubt. People were here working stone and bone, carrying material 200 miles in the same centuries the burning tree mastodon died in a kettle pond 70 miles to the southeast, which makes the burning tree problem sharper rather than softer. The people were demonstrably present. The animal was demonstrably there. What has never been demonstrated is that the two of them ever met. Sheridan is not the only place in Ohio where those people left objects behind, and the rest of the record makes the gap at Burning Tree Stranger not easier. Go northeast to Medina County and the Paleo Crossing site. David Brose, then at the Cleveland Museum of Natural History, led the investigations and published on them in 1994. What came out was charcoal from refuse pits and the stone. The stone is the point. In 2015, Matthew Boulanger, working with Briggs Buchanan, Michael O'Brien, Brian Redmond, Michael Glasscock, and Meaton Aaron, published a neutron activation analysis of the Paleo Crossing artifacts in the Journal of Archaeological Science. Neutron activation works by bombarding a sample with neutrons and reading the gamma radiation the excited elements give off, which produces a chemical fingerprint precise enough to match a worked flake to the specific outcrop the raw material came from. The result was Wyandotte Chert from southern Indiana. The straight line distance is between 450 and 510 kilometers. Take a moment with that number. That is 300 miles on foot across a landscape without roads, carrying stone. And this is not one exotic piece traded down a chain of hands. It is the bulk of the assemblage. Whoever camped at Paleo Crossing around 12,900 years ago had either walked from southern Indiana or was maintaining a relationship with people who had. Then go east to Stark County, to Noble's Pond, near Canton. 25 acres. It is one of the largest Clovis sites in North America, excavated in large part by volunteers, and it has produced enough material to show how tools were made, where the stone came from, and how the site was organized. And in Columbiana County, in the northeast corner of the state, there is a case that deserves attention precisely because of how carefully it was handled. A mastodon was recovered there, known as the Hartley mastodon. About 700 meters away in a plowed farm field north of a tributary of the Mahoning River, a landowner named D. Jackson found 5 Clovis artifacts. The base of a fluted point, a preform base with the prepared nipple that nappers shape before striking a flute, a large flake, a biface tip, a biface midsection. 3 of them lay in a cluster under 10 meters across. Michelle Beber, Logan Miller, Matthew Boulanger, Brian Andrews, Brian Redmond, Jackson, and Mitten Aaron published the analysis in 2017. A mastodon and Clovis tools 700 meters apart in the same county. And their conclusion was that there is currently no strong evidence linking the two. That sentence is the discipline working properly. The temptation was obvious, and they refused it. What they argued instead was the modest thing the evidence supported, that the location would have been attractive to Clovis groups for ordinary reasons, chief among them a glacially deposited secondary chert source sitting right there. So set the Ohio record out as it stands. At Sheridan Cave, tools and bone points dated directly, but no mastodon. At Paleo Crossing, stone carried 300 miles, dated and no megafauna. At Noble's Pond, one of the largest Clovis occupations on the continent, and no kill site. At Hartley, a mastodon and Clovis tools in the same landscape, and researchers explicitly declining to connect them. And at Burning Tree, the most complete mastodon skeleton in North America, carrying marks that look like butchery with no stone tools at all. Every site in Ohio has either the people or the animal. None of them has both, tied together, beyond dispute. That pattern is not unique to Ohio, and it is not evidence of anything mysterious. Kill and butchery sites are rare everywhere because the conditions required to preserve one are unusual, and the conditions required to prove one are more unusual still. Across the whole of the Americas, the number of proboscidean sites with unambiguous butchery evidence is small, and only a single assemblage anywhere has produced a bone with a possible weapon fragment embedded in it. Which brings the question back to where it started, and narrows it. Not whether people were in Ohio. That is settled to within 30 years on a bone point from a sealed cave. The question is what happened in one kettle basin in Licking County, and whether the 4 kinds of damage on that skeleton were made by a hand or by the ground. Start with what the peat gave up beyond the bones, because it is the most underused evidence at the site. The gut contents were analyzed, and they changed something. The assumption had been that mastodons in the Great Lakes region browsed heavily on conifers, on spruce and fir, because that is the vegetation the pollen record puts on the landscape. What was actually inside the burning tree animal was twigs, bark, and a substantial quantity of lush aquatic vegetation. The diet looked less like a spruce forest browser and more like a modern moose, an animal that spends serious time feeding in and around water. That matters for the argument in a way that cuts both directions, and it is worth being honest about both. If the animal fed in and around ponds, then a mastodon dying in a kettle basin needs no human explanation at all. It was in exactly the habitat it used. Animals die in the places they live, but the same finding also puts the carcass where Fischer's argument requires it to be: cold, oxygen-poor water in a glacial hollow, deep enough to hold meat, right where the animal already was. The gut contents cannot decide between those two readings. They are consistent with both, which is precisely why they have never resolved anything. Then there is the stratigraphy, and here the site has always been vulnerable. Thomas Frolking worked on the late Quaternary environments and landscape evolution of the basin and presented on it in 1994. The deposit is peat in a kettle, and peat in a kettle compacts, shifts, and loads unevenly as it accumulates. That is not a neutral setting for reading damage. Weight moving through soft, saturated sediment for 11,000 years is capable of breaking bone and smoothing surfaces, and a skeleton lying articulated in that matrix has been under continuous pressure the entire time, none of which is proof of anything either. It is the same problem in a different form. A process that could have produced some of the damage is not a process demonstrated to have produced it. And notice what the site did not contain, because it is the mirror image of the missing stone tools. There were no anchoring stones at Burning Tree. At the Michigan site, Fischer's case rested partly on masses of sand and gravel resting on the pond floor, which he read as ballast packed into the animal's own intestines to weight the meat down. Licking County produced no equivalent. The strongest physical signature of the caching hypothesis, the one piece of evidence that is a thing rather than a mark, is absent from the site the hypothesis is most famously attached to. So the honest position on Burning Tree is this: 4 independent lines of damage occurring together in a coherent pattern, argued by a researcher who developed the method and tested his own hypothesis by eating pond stored horse for months. Against that, no stone tools, no anchoring stones, a depositional setting capable of producing some of the same damage on its own, and a co-author who has spent 35 years saying out loud that he cannot fully accept the conclusion. Both readings remain live. Neither has been closed. Lepper's own view is that without stone tools placing people at that spot, they may never be. And there is a limit worth stating plainly, because it gets misreported. Burning Tree does not push back the date of human arrival in the Americas. It never did. The animal died around 11,500 radiocarbon years ago, comfortably inside the range when people are known to have been in Ohio. The site has never been a pre-Clovis claim. What it is, and what makes it genuinely difficult, is a test of whether we can recognize human behavior at all when the people leave nothing behind but the marks of the work. Go back to the dragline. A man cutting a pond on a golf course in December, a bucket catching on something hard, and a decision to stop. Everything the site has given us for 35 years exists because of that. The skeleton is still the most complete in North America. The gut contents are still in the ground record. The cut surfaces and the polish and the spiral fractures are still exactly what Fischer described, and there is still not one stone tool. Archaeology is comfortable with objects. Give it a fluted point in a sealed layer, and it will hand you a date to within 30 years. What it struggles with is behavior that leaves no object behind, and most of what people have ever done leaves no object behind. The question at Burning Tree was never whether anyone was there. It was whether we would recognize them if they were.